Hi everyone. We will be waiting just another 2 to 3 minutes before we get started to accommodate the rest of the attendees who are in the middle of connecting. Welcome everyone. I'm Heike Ritter and I will be your host for this webinar. Thanks for joining and thanks for being part of our community. A few reminders before we start. This webinar is being recorded and will be shared publicly afterwards in our community at aka.ms/security-webinars. During the webinar, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Questions you post will be visible publicly, and if you prefer, you can post your questions anonymously by checking the box right below where you enter it. We often get many questions during the webinar and are doing our best to respond to all of them in real time. If the answer was not provided or if you have additional questions afterwards, please don't hesitate to ask them on the Microsoft 365 Defender forum at aka.ms/m365dtc. If you're listening to this after the fact as a recording, you can also use that place to ask a question. We love to hear your feedback on how we can improve these webinars, so this is really important, and please do so at aka.ms/security-webinar-feedback. This is important, so we can deliver the content you need. And if you haven't already, please join our community at aka.ms/security-community, and that's the best way to ensure you don't miss any future webinars or major announcements. And in our community, you can speak directly to the engineering teams that are actually building those security products. For Microsoft 365 Defender, you can do that at aka.ms/m365dtc. And we believe that this is the best way to improve our products by removing any barriers between you and the people that actually create them. So please join us. Today, I'm super excited to have Elif Kaya talk about her extensive research and the learnings, what tracking and an attacker email infrastructure tells us about persistent cybercriminal operations. So handing over to you.
Thank you. Hello, everyone. Thanks for joining us today. I hope Monday is going well enough for everyone here. My name is Elif Kaya, and I work at Microsoft as a threat analyst with the Microsoft Defender 365 threat intelligence team. I specialize here along with my team in phishing and email investigation and have dealt with infrastructure previously and identity and network related threats and roles. So let's get started. This presentation is going to essentially be covering a little more in depth a blog that Microsoft recently released for those that are had the chance to pre-read it. and for those that didn't, which covered a set of email delivery infrastructure, which we monitored from March to December. And we can change to the next slide. For a little bit of background on that, this infrastructure, when we say the word infrastructure, we're talking about a series of 4 lease operations of mail servers, domains, and formats that were utilized during these months to deliver a very wide range of malware. In the blog, we reference other botnets and delivery mechanisms for phishing and malware that we've seen in the past, such as Nickers and Cutwhale. And we refer to the 2 infrastructure that we're going to cover here as strange U and random U. The strange and random portions referring to a portion of their domain generation algorithm, and the U referring to the fact that they use primarily .us domains. Though it's important to note that during this time, though these are the 2 infrastructures that we're covering, there were countless other network and email delivery infrastructures that were spun up and utilized to deliver malware during this time. The reason that we are highlighting this today on the tail of the takedowns of such botnets and even the Emotet news of late is really to impress upon everyone the modular nature of phishing attacks and malware that we see routinely, and in order to assure that we combat phish and enact threat intel in a way that is holistic and that we are not focusing too heavily on any one malware strain, any one attacker. So to get down to business, we track this from March to December, March being the time that we first observed registrations and deliveries with these email infrastructures. And at its peak, the random U, I believe, was delivering up to 10 million mails a day, but an average overall of more than 1 million a month. What we notice with a lot of modular infrastructures like this is that there are many days that they deliver nothing and days where they deliver a lot of mail, which we'll refer to in the rest of this blog and this webinar as campaigns or runs that primarily someone or malware operator will lease use of the email infrastructure in order to send mail for a small amount of time. So we observed at least up to 7 different malware families distributed, some in routine multiple distributions and some only once or twice. We did notice a heavy concentration, especially towards the end, with focus in Australia in particular and the UK. There was a general US concentration, though that may be because of our general data and customer base being in the US, and a lot of malware will target the US in general. And in the early stages of Strange U and Random U, we also noticed some geographic campaigns targeting Korea and other regions. While it may come as no surprise that the wholesale distribution of financial services and healthcare are kind of in the top 5 industries that we saw targeted, we are seeing distribution and healthcare continuously move up and be present in that top 5, though financial services is no surprise here. Okay, we can go to the next slide. So the kind of things that we learned from tracking this is some of it things that we already had known before and that I imagine many of the defending organizations here also know, but tracking and pivoting on email infrastructure, especially email infrastructure that operates as a service to malware operators, allows us to connect disparate campaigns in ways where if we were only tracking the malware itself, it would be more difficult to get ahead of the next deliveries. And so especially in the cases that we're outlining today, the malware operator's decision to use proxy connections like this in order to lease out their mail deliveries can sometimes make it easier for defenders to get ahead of the next delivery and protect against multiple types of malware rather than just one, even in cases where the malware is very commodity or would be very easy to defend against, or cases where the malware is a lot more evasive. So we also observe that when we talk about the domains that are going to be used here, the term domain generation algorithm will come up. What this generally refers to, for those unaware, is just a domain that looks very random and is likely created in an automated way, and usually at large scale. And so through observing and kind of diving deep into each of the malware campaigns that we observed here, we confirmed something that we've noticed before, which is that despite DGA being a pretty popular term in machine learning circles, DGA is frequently restricted for use in email delivery mechanisms or these kind of modular for lease mechanisms rather than C2 of the individual malware. We're still seeing direct IP allocation used for C2 frequently or compromised domains. If we're seeing DGA used for C2 for malware, command and control, it's frequently in very small quantities. So while it may look random, while it may be random, it'll usually be in bursts of 5, 10. C2 will generally be the smallest, email will generally be the largest, no surprises there, but it's still, especially as we start talking more about infrastructure and more about DGA, a worthwhile point. As we talk about the other botnets involved as well in the past, malware operators, though threat intelligence tends to focus very heavily on APTs and the kind of sole threat actor, threat organization, at any given point in time, most of the malware that we discuss and that we see in the news is likely using many proxies and many modular pieces of infrastructure, whether that's leasing the different sites in order to host the malware, leasing different sites in order to deliver the malware, and with the rise of ransomware as a service, potentially not weaponizing it themselves either. So information, hopefully this is helpful to the organizations on the call in order to kind of more holistically understand what it looks like just over, two to three seasons of operation of one of these infrastructures and kind of what they delivered and what that timeline looked like. So we can go to the next. So here's just a breakdown of kind of these months of operations. Netcours was a previous botnet that was taken down last March. They operated in a very similar way. It infected machines in order to use them to deliver phishing malware. At its height, I believe Netcours had delivered up to 10 different malware families. And so very shortly after the notice of this, we began to notice and keep track of other infrastructures that were kind of filling that same void. Domains that started to be registered with mail subdomains that we noticed that weren't being used to send legitimate mail, but were being used to send in this kind of burst pattern that is very familiar with phishing. So Strange U is our first contender that we see, registered a whole month before Random U, and I guess I'll add a caveat that these two infrastructures, for the sake of our discussion here, could be considered to be operated distinctly. There are campaigns where we will talk about them being operated simultaneously to deliver the same malware, but again, due to the modular nature of these kind of things, we're going to consider them distinct. So mailing for both of these begins right away, and at first we begin to see that it is highly likely that these were stood up and advertised for either the first time or were in their relative infancy in terms of awareness. The first few campaigns that we saw on Strange U and Random U were very commodity. Strange U in particular had a much longer running start of trying to seemingly get more expensive malware. The first few malwares that we saw, which we'll cover shortly on Strange U, involved very commodity malware that might have been under $40, under $15 a hit. Whereas when we saw Random U begin to deliver all the way through the end of the year, pretty much off the bat, they were able to get Drydex deliveries and deliveries that kind of have a little more weight and were a little more close to the delivery profile that we saw in Netcours at the time of takedown. Strange U towards the end did start delivering quite a bit of Drydex between the summer and December, but definitely started with a lot more of the mix and variety malware. Cool, and we also note here kind of when registration ended for each of these. Generally, registration for a particular set of domains would start and there'd be 5 or 6 domains registered, used within the same 1 or 2 days. So keying in on the patterns ahead of time was really critical in being able to identify campaigns ahead of time. Though with both campaigns, there was a demarcation point where registration ended and the campaigns or the domains from older registrations were still used. Cool, so here's an example of what we've been talking about so far of what these kind of domain registration patterns are. So on the left we have Strange U and on the right we have Random U. it's not very clever names per se, but strange being that most of the terms that we saw in the around about 200 domains involve the word strange and a series of other combined words in order to make up the domain. And on the right-hand side with randomu, obviously the next time there's a DGA that uses .us, we couldn't use randomu, but for the most part, this is just using a pretty standard DGA algorithm, most likely, in order to register these domains. Okay. So to go back basically to the timelines that we observed before, here's a breakdown of some of the bigger ones. And at one of those Monfoxias is actually Machop, the Machop ransomware, but we can get into that in just a moment. But yeah, at the beginning we saw Monfoxia, code for Diamond Fox. Machop runs pretty regularly, as well as some Doughfoil or Smoke Loader. And it really began to get on the scene when we saw it used in a very modular fashion with some well-publicized Trickbot and Drydex runs in July. And then towards the end of StrangeU and RandomU, there was one period of time where StrangeU and RandomU both ran in the beginning of September a Drydex run together. And then after that, RandomU continued that same campaign of Drydex runs, so same TTPs, same lures, same payloads, pretty much same exact kill chain, but continued the delivery of those every few weeks through the beginning of September, all through the end of December. And in October is when we saw the biggest spike of about 10 million Emotet and Drydex delivered in one day. I say Emotet and Drydex, and we'll cover that later, because Emotet was used as a loader in these cases in order to deliver the Drydex second stage payload. Cool. So one of the first major campaigns that we saw, which kind of highlighted the modular infrastructure here, was the delivery of Machop phishing emails. So Machop in April of 2020 had already been well known for delivering to Korea very regularly in direct email phishing, especially email phishing that simulated resumes and simulated kind of job applications. And that's the same technique that we saw here. The interesting part here is that all of the Machop previously and all of the Machop after this individual campaign was delivered through more traditional infrastructure, so compromised domains and things like that. Our best hypothesis here is that this kind of highlights, at least for one period of time, where the traditional infrastructure that the Machop operator was using was not available. And so they at least took out one run or one campaign from StrangeU in order to deliver these ones. The TTPs and the individual emails were nearly identical to all of the emails, including the payload of the Machop emails delivered not through StrangeU and RandomU, which leads us to believe, again, that this was a modular use of a one-off situation. The payload here was delivered as a zip with an EXE and specifically targeted to appear like it was someone seeking employment at a variety of agricultural and manufacturing organizations in Korea, as well as being direct delivery. So recently, Microsoft has talked frequently about human-operated ransomware. These deliveries, as well as most Machop deliveries that we observe, are direct ransomware deliveries. So there is not a human-operated element, and as soon as the executable runs, the expectation is that it immediately will begin encrypting and ransoming. We noticed actually multiple runs using this. So in April, we saw a fairly large campaign utilizing StrangeU to ship Machop, and then about 6 weeks later, we saw another one. The only difference tangibly between these is that between the April and the May runs with Machop, we noticed that the Machop payload itself had advanced slightly, and we're using more evasive techniques such as requiring a reboot, deleting more instances of backups, and etc. Oh, and it looks like that's actually the June variant. yeah, several short bursts used legitimate vendors prior to moving to strange use. So these used free email services. And again, at some point in time, the free email services may not have been available. And so the use of the strange use came into play. We also see this kind of particular tactic often when malware operators are using legitimate hosting services as well. They'll have to move to a different hosting service when they receive enough pressure from, say, Google Docs, which is very popular lately for hosting malware. For a period of a week or more, they might be unable to host there and will have to host somewhere else for at least one run. The next major campaign we saw that was non-commodity malware was a Trickbot campaign that was heavily publicized. This was actually one campaign that we saw delivered through StrangeU, but about 2 weeks prior to this Trickbot campaign, there was an identical campaign assuming to be some kind of phishing mailer asking for people to take a survey about their opinions on variations of the term Black Lives Matter, including Whose Lives Matter and etc., in order to vary the lures of the email. The email itself was fairly simple and just contained a Word document, and this targeted almost exclusively the US and Canada. One interesting thing we noted about this is that the initial attack from 2 weeks prior, which was identical in every way, including the C2s and the C2 behaviors, used only a set of about 6 to 7 .monster domains to send their mail, but they still used owned domains rather than compromised. And we noticed that same behavior here 2 weeks later, where they used a mix of self-registered domains that actually emulated Black Lives Matter, BLM, Whose Lives Matter, .site, and .space, and they intermixed that with the strange and secure world domains. So we actually began to piece apart the ways in which they used the .monster domains before, and the ways in which they used other registration-specific domains for this campaign, mixed with the more generic StrangeU domains in order to deliver and kind of bolster the volume of email addresses they were using to send from, and by proxy email servers they were using to send from. The Trickbot payload here also came during a time where Trickbot had released quite a few new versions and ways to be evasive. And so through the infections that we were able to identify, they frequently tried to evade sandbox detection, which did work in quite a few instances at the time, though it seems like on VT, most instances are covered at this point. There's actually quite a few good write-ups on the Trickbot payload from this period of time. But once it was installed, it hijacked the Windows Error Manager in order to drop Trickbot payloads using an odd.dog extension, which we had not seen prior, and I don't believe we've seen after. But during that, it was used to scan ports in order to move laterally and collect data, as well as exfiltrate, which is fairly common for Trickbot, exfiltrate the browser caches as well, and scrape credentials to exfiltrate those externally. Okay. So during this time, we had also seen some runs of Diamond Fox and other more commodity malwares as well. But it took until about June, late June to July, that we began seeing Drydex campaigns. So the first Drydex campaigns were a lot more simple. We have 3 distinct types of Drydex campaigns that we'll talk about here today. This initial set used standard Excel documents with malicious macros, which is part and parcel for, honestly, almost all except for Machop, I believe, of the malware campaigns delivered, which, spoiler for things that can probably be used to cross-detect multiple malware families. The initial infection began with StrangeU domains, but quickly additionally used compromised email accounts in order to further add bulk to the amount of senders. Our theory for this, and likely the theory for most modular domains in general, is that compromised senders are going to be the most coveted and most valuable types of sending and mail infrastructure, because it's often going to use legitimate infrastructure to send the mail and mail servers, and it's going to use infrastructure that's very unlikely to be marked by any kind of ML as bad if it hasn't been used before. However, those accounts can, as we've seen, be hard to come by in certain cases when there's a lot of demand on them. And so in cases like these Drydex campaigns, where we initially see them use just strange U, and then we quickly see them use strange U plus compromised infrastructure as well. And again, the linking between these being that multiple indicators in the actual payload as well as in the mail themselves were indicative of it being an identical mail campaign, just spread across multiple clusters of mail servers. And so one of those overlapping attributes that we have to detect those, that is also pretty useful to detect those, not in every type of mail campaign, surely, but there is quite a few malware operators and malware senders we've seen who structure their campaigns to use not only a reply to address that is different than where they have sent from, but a reply to address that is a separate compromised piece of infrastructure. So one of the more common phishing tactics, of course, is that the reply to will be the recipient. But in this case, the reply to was actually a separate subset, which was the smallest subset available of only about 2 to 3 unique compromised reply to addresses, where in a set of maybe, let's say, 50 or 60 sender domains and 7 to 10 C2s. So the reply to address here was one of the smallest points of contact. So attached Excel files pulled a payload from .xyz domains. These also, while they could be considered DGA, they actually comprise about 3 to 4 different clusters in terms of who is registration fingerprints and time of registration. So we see these mostly in linear order, and there's about, I think, 10 or 12 more of these C2s that occurred during this time, but they all serve the same function, which was to host the initial payload that was pulled from the Excel macro and to kind of serve as the kickoff there. And so that was also an indicator to find additional Excel payloads in new email campaigns. But for the most part, this was very traditional. This was very traditional Drydex that we'd seen in the past, delivered straight from the Excel macro itself, or delivered straight from the delivery domain. So as we saw this evolve over time, we actually noticed that interspersed between about 6 to 7 solid weeks of the campaign we described previously, which used those kind of guru of bullet.xyz kind of domains, we noticed one that was a bit of an outlier that only ran for 1 to 2 days. This is the what we would theorize is either a test payload or just kind of a variant of Drydex that was run in this that we have seen definitely less frequently, where some of the variants actually used Shakespearean prose in order to obfuscate their VBA scripts and their macros. And so this used quite a bit different evasive techniques and was much more evasive than the previous Drydex campaigns, using VBA purging in order to avoid detection of the malicious macro, which kind of reinforces the need for either an intense evaluation of the macro policy within an organization, or the use of the ASR rules, or in order to prevent office execution and macro execution due to the increased evasion techniques that are used by these kind of documents. And so what we noticed here was, again, this more evasive version of Drydex ran for only a day, used a Word document instead of an Excel document. And again, it was pulling from a bathermium.com, which there's a great write-up on DFIR reports blog on exactly what kind of happened after infection on that instance, which eventually involved PowerShell Empire and human operated maneuvers happening pretty quickly on the box. And so by tracking this email infrastructure, we were kind of able to observe these interesting evolutions of the Drydex campaigns over time, including this kind of very unusual one in the middle. though oddly enough, poetry has been used as a way to evade detection before. The way that we saw it used in this particular campaign involved more than likely a kind of polyscripting technique where each function and each time the document had a unique variant, each function had pulled from an open repository of literature in order to randomly name its function names and code within, so that each document was very tangibly different. Cool. So after this, we began to see the first instance of Drydex being delivered by StrangeU and RandomU simultaneously. So RandomU had been delivering some Drydex prior, but what we observed on September 7th and then all through the rest of the year was a particularly evasive, again, more evasive than the initial Drydex, and I believe at this point in time, a lot of vendors on VirusTotal and etc. still struggle with detecting some of these due to the PHP redirection that occurs in this campaign. And so it was using an Emotet loader initially for the infrastructure hosting of to deliver the malware. And what we would see is emails delivered with about 3 to 5 URLs in them, most of them going to URLs associated with already compromised Emotet WordPress sites. And initially, in the very beginning of these Drydex runs, likely when they were still testing to make sure it worked properly, we noticed only 3 distinct .phps, these 3 Z, X, L, B, W, and etc. run for about anywhere from, I believe, 2 days to a week of runs, only use these 3 .phps. And then after it seems like it got its legs under them, it actually expanded into a set of maybe 40 to 50 different dynamically generated .php endings. And so what that looked like in the email is that one of those 3 to 5 links, all of which would eventually turn back around to it, it would do a series of sandbox evasion here and eventually redirect the user to a page where they would have to manually click in order to download a malicious Word document, which contained the Emotet loader, which then loaded Drydex from a secondary source. And so, yes, the later campaigns kind of evolved in maturity. They had more dynamic behaviors. They used a larger subset of sending infrastructure as well, and they continued to send through the end of the year every few weeks. And again, I guess as spoiler, if it wasn't already mentioned before, macros as well is a kind of delimiting factor here. So yeah, heavy sandbox evasion here as well. The Word document was actually contained inside of a zip first in order to download the Word document, which launched the macro, which then launched the DLL. Yeah, and so there was pretty standard persistence through reg edits here, as well as callbacks through and pivoting through Cobalt Strike later. Okay. Should be good to move to the next one. So we cover some of these campaigns slightly more in depth in the blog. And again, especially Trickbot and Drydex that we've covered here have a lot of good write-ups as well if you're interested in kind of more of the endpoint side of the house here. But kind of the narrative that we wanted to share here is that as infrastructure, especially cloud infrastructure, gets easier and easier to deploy, easier and easier to build, we're not seeing a comparable level of effort in order to defend against the infrastructure itself. We're seeing a lot of effort invested by attackers in order to make sure that their malware is evasive, even using the Shakespearean prose and using BBA stomping and purging and etc. in order where we can see the malware operators becoming more evasive in their malware, but we can see over a period of 9 months that they've done nothing to become more evasive from their infrastructure. And so many of the C2s here, many of the email delivery domains and the mail servers themselves were able to be monitored very simply, both by Microsoft and also likely by any defender that has access to whois data, registration data, and a really good visibility into their mail header data as well. But the attackers aren't investing in protecting the infrastructure, they're investing in protecting the malware itself. And so this modular nature that we're seeing over time actually poses a very large gap in the attackers' own defenses of their malware that defenders could definitely try and improve on detection of in order to detect against malware ahead of time. And also to enrich their threat intelligence programs. And so we're definitely seeing ISPs and cloud service providers, as they scale up, we're also seeing attackers use them more often. So Microsoft Defender for Office offers quite a few things that we recommend that people turn on all the time, especially if they're already paying for those services like safe links and safe attachments, so that there's scan at click and scan at delivery. And that we're making sure that those that have endpoint protection with us are turning off their cloud protection as well, so that again, at delivery, it's able to be detected and at click, and it's able to be continuously rescanned if that determination changes. So we use a combination within Microsoft Defender for Office of ML and our standard protection suite. And we, as the threat intelligence team, try and enrich and identify gaps within the product and for the customers with this kind of threat intelligence, so that we're sure that we're able to look holistically over a long period of time and say, here's the trends. Okay. So some of these are pretty straightforward in terms of just making sure that you have a pretty baseline phishing education program. Probably an additionally pretty large component here is making sure that you are, especially if you're using Microsoft for your email protection and Microsoft for your email servers in general, to make sure that you're regularly checking your configuration policies with the configuration analyzer as well as manually. So we did observe many instances in which campaigns that would have normally been caught via phishing and malware protection would get through on allow rules. And so what that ends up looking like in a customer environment is generally the allow rules that might be in a tenant might allow entire IP ranges or entire domain ranges, or particular mail servers in general. And especially in these types of modular campaigns, attackers are very well familiar with the types of IPs that are generally allowed. And so there was a substantial number of phishing mails that were associated with these kind of campaigns where you would look at it and you'd say, why would somebody allow these kind of things? But it's usually those kind of accidents. So definitely try and use Configuration Analyzer if you do use us for your mail services. And as I mentioned before, not only safe links, but make sure, and I believe that this is enabled by default, but somebody can probably check me on it, that ZAP is enabled. I believe this is similar to Proofpoint's trap service, where if a phishing mail is delivered to inbox and Microsoft finds that the determination is different after the fact due to incident response or some other determination, ZAP will pull that email out of the inboxes that it was delivered to post ex facto. Again, disallow macros or only allow macros from trusted locations. While this is often touted as just like, oh, everyone should be doing this, we do allow more granular, which I'm sure that everyone is a bit familiar with. We do allow more granular toggles now for what you can and can't allow macros to perform, as well as what kind of downstream executions VBA scripts or macros are allowed to launch from Office documents. And so our ASR rules, of which we highlight a number of our recommended ones in the blog post itself, can work really well here to allow users to use macros in regular situations to enable productivity and still restrict macros from being able to execute the kind of malware that we see. And additionally, we have released features in order for you to test the impact of these ASR rules ahead of time. So if you're still worried about the impact on productivity, any kind of macro restriction will have, there is features that we detail in the blog about how to test ahead of time. And then some of these are kind of going to be a bit more amorphous to the individual organization, but make sure to enable AMC and assure that you have some kind of threat intelligence feed system so that if you do receive information about this kind of material, that you're able to quickly enact it on your endpoint and at your firewall or any kind of network protection that you're currently using. Okay. Yeah, and so here's just a copy here of the ASR rules that we outlined in the blog as the most pertinent to the malware campaigns that we describe here. Again, due to the fact that we've covered 7 or 8 different malware families here, despite their varying differences in both price range and evasive capabilities, there are some of these that, if enabled, would likely stop most of them. And without the need to kind of match the amount of investment that the operators are putting into their malware, but at a much higher level, again, at their kind of bread and butter macros and mail delivery. And again, to kind of wrap us up, we have some advanced hunting queries for those that have the Microsoft Defender ATP product that we have available in the blog in order to defend some of these domains. For those that have not already been using them, and for those that have, excellent. I hope that you very much enjoy the product, but it is currently general availability that all emails delivered or not delivered should be able to be parsed in your environment via the email tables available in the advanced hunting feature. So if you're looking to find header information, message IDs, sender mail addresses, including the kind of spoofed ones and etc., or disconnects between them and subjects as well, you'll be able to make fairly advanced queries here in order to do your own email investigations and scope them as you wish. Again, we've included one of those in the blog here. We also have a public-facing GitHub for those that are not aware, which hosts a large amount of both hunting queries that Microsoft has provided and hunting queries provided by the community that can be used for this. Again, email currently is general availability, and we have both ability to query on message and header information in the mail, as well as URL and attachment information in the mail. New features are being added routinely, as well as in the future, identity and MCAS related data, I believe, are in public preview right now as well. So definitely, if you haven't checked out Advanced Hunting, highly recommend it. It's a great tool for your SOC analysts. Okay, I think that that's about all that I have here. Again, highly recommend check out the full blog and dig into the different products as well.
Thank you, Elif, so much. So just to add what you just said. So I just posted the link to the blog as an announcement into the chat window. And then also, first of all, thank you so much, Elif. That was awesome. So many rich insights into your research. Everybody can read the full blog again. Again, I posted it. Talking about advanced hunting, we did a educational advanced hunting series as well here on aka.ms/security webinars. So if you go on the webinar registration page, you can see further down are the links to all the recordings, and there is tracking and adversary was the series, and you can start by 0. And then Michael Malone and Talia Ash, they just walk you through expanding your knowledge and then become an expert hunter across your M365 data. Okay, again, thank you very much, Elif. And I'm going to close this webinar, but a couple of reminders before I do so. So we have a few new, of course, webinars coming up. I'm just going to mention 4. One is February 23rd. It's about Azure Security Center or Azure Defender. best practices for improving your secure score. March 9th is Azure Defender for storage. March 11th is Cloud App Security, how to protect your GitHub environment using MCAS. And then March 16 is Diversity in Cybersecurity, where we have Sue Lowe, software engineer at Microsoft and author of the young adult hacker novel Raven, inspires girls and others underrepresented groups to enter the tech. For all the details and registration, go to aka.ms/security webinars. And I think I need to actually move forward with my slides. So, and then if you missed, if we missed to answer your question, or if you have additional questions, you can visit the Microsoft 365 Defender forum at aka.ms/m365dtc. Again, thank you, Elif, for today's session, and then thank you to the rest of your team who helped answering all the questions in the background, and most of all, thank you for being part of our community and for joining us on those webinars. Give us feedback, please, so that we know how we can improve the webinars in the future for you. Also, please send us love for things that we are doing good. So we hope to see you next time. And with that, goodbye.